This is persistent route oscillation. Dave Warden, perhaps I would like to know how many people care about persistent route oscillation. First, I guess I'll define it. Okay, I do at least have, Dave's got 2 hands. So good, there's at least some people. One thing we ran into in the IDR working group last ITF is we couldn't define the problem or who cared about the problem. Oh, okay. Oh boy, I've got checkbooks that were found in the bathroom, so if you think you may have lost something, come up and see Susan, she'll have them. Okay, so we're going to try to go through the issues and solutions. I'm going to go through the problem. John, I'm Sue Hares, I'm with Nextop. Anchor's going to go through the BGP route oscillation reduction. John's going to go through as far as the single path solution, and John's going to go through the multipath. And then Anchor's going to talk about detection and deployment. I feel like I almost breezed right in there because Anchor and John and I have been working for a while. I think we date back to all old Merit folks, but Anchor is currently at Redback and doing lots of really interesting BGP work for the last 10, 15 years, about that, something like that. He was at Internet MCI and Redback, and where else have I missed? Cisco, oh, that other word, you know. And John's at Cisco, and before that was with ING and AADS. Did I remember everything? And then Merit. So we've been together and we've been working on some of these problems for a while. And one thing I think that's most important is we'd like to know who cares if you have problems in your network. If you'd send any of us a note or send the IDR list a note, we'd really like to find out because we got to a question of what problem we're trying to solve. With that, I'm going to talk about the problems in route oscillation, and some of these slides after I read it over last night, I must have had one too many beers at the beer and gear. So what we aren't solving, we're not solving route selection rules. We're trying to really solve that in the latest BGP draft work. 18 is yet coming out. And we're going to discuss 2 problems here, route oscillation with MEDs and route oscillation without it, and we're going to talk about reductions. So let me go through what we're not solving. We're not solving this route selection. If you look at this pyramid, it'll tell you what we're working on as far as route selection, AS path, low storage and MED, EGP or IGP and IGP path. The last 3 are where you'll see when things get inverted that the oscillation occurs. Well, I said in here the good news is it's done. I think we've got a good thing as far as the consensus on route oscillation. I showed it to someone else and they said, no, I think there's still things left out. Well, send that to the IDR list. We always like more fodder for the grist mill there. In case you're not all on it, the IDR list has been extremely active in the last month to the tune of my mailbox dies every day. What is the goals of route oscillation changes? Well, we're trying to get BGP so it should be stable and converge. We want less constraints on the topology for route reflection, AS confederations, and IGP metrics because what we thought we understood from the ISPs is this is important. They don't want to be constrained. And we want it to be robust under as many circumstances as possible. Okay, so here's one example, and I do need to mention that this may be a bit contrived and might not be as natural as some of the examples. But in this case, the node underneath there is announcing EGP routes to C1, C2, and C3, and then they announce it to the respective routing reflectors. And then the route reflectors, and I suppose R1, R2, and R3 actually then advertise their clients' routes to each other. The route reflectors recompute the routes and then withdraw their advertisement. This results in the eventual removal, and this goes through and through. So this is a contrived example, but it shows you that due to this interaction between the IGPs and the IGP statistics and route reflection, you can actually have over-reduction and you can have the oscillation. Now this is my favorite example. This is from RFC 3375. I think that's what I have in my other thing when I looked up the RFC. You can find all of this example. Now, this has to do with the fact that you're not doing You're not using any of the BGP MED knobs. You're actually looking at the AS path and the MED. So, for example, the initial route comes into A and B, RB and RC, and in that case, you have gotten it from a different AS, so you don't compare the MED elections. You use the IGP metrics, which is 4 and 5, to compare it, and select RC. RC is sent to RD. RD then turns around and selects RE. Well, then RA and RD announce each other's routes, and RA computes the best route because now RA has RE, which has has a previous AS of 6, and RA has a previous AS of 6, and selects via the MED, which picks up RE. RE then says, okay, I'm going to announce each other, and you end up selecting RE. RE is then sent back, and RB and RE are compared, and you then select the fact you should reduce RB. You then come back and say RE will force RA to reduce that, and again you come back to where once you've reduced RE, you have RB and RC is the thing, and then the whole pattern starts over. If you look at the RC, or if you look at my improved slides, which didn't make it up here tonight, this afternoon, you'll go through these particular sequences. So the route withdrawal is a culprit for the route oscillation. So when these BGP updates come, sometimes you have the circular redundancy, you have a restriction of information by the route reflection of confederation, and you have a partial ordering due to MEG. So this route selection is oversensitive to the route information. It seems to play a role that we might not have intended. When we first started out with multi-exit, we were just trying to make sure we could pick between an Ethernet and perhaps a serial link or something that was less bandwidth ready. So right now, we really can't do the changes to the current protocol on the deployed base. So why are we just pretty much saying route reflectors here? This is actually true of AS confederations. In principle, they can be equivalent because you can treat AS border routers and confederations as route reflectors and their IBGP as clients. And so the confederation eBGP is non-compliant. So it's about the same because you actually find the same amount of reduction of information. Confederations are usually deployed as a 2-level hierarchy, and the ABSRs are fully meshed, so again, you lose information, which probably is what's happening to your brain right now. If you go later and pick up the improved slides we didn't get up, you'll find that you can walk through it, or you walk through the RC, because this problem, although interesting, is probably a difficult one to watch. There are 2 solutions that we're going to look at. There is the single-path solution that Anchor has, and a multi-path. Then we'll talk about the route oscillation detection and deployment.
Okay, so my presentation focuses on the single-path solution. Okay. Yeah, actually, some of these points have been basically just talked about by Sue in Sue's slides. So here, let's look at there are a couple of observations on rod reflection and also that involving the rod oscillation. So the first point is that currently a rod reflector only reflects the base path. So what it means is that if the base path for rod reflector is from a non-client peer, is basically from another cluster, and then basically this rod reflector will not advertise any of its client paths to other clusters. So this, it's due to the sequence of events. If the client's path has been advertised to other clusters, that path needs to be withdrawn because it only reflects the best path right now. although the Clyde path is still valid and is still available on the reflector, but that information will not be made available to other clusters. As shown in the, actually in both cases that in Su's slides, but the first case in particular, it is a withdrawal by the rod reflector that they did completely remove the Clyde's routing information from other clusters. And so there exists over reduction of routing information by rod reflection if you compare with the case of a full RDDP mesh. Another observation is that if we modify the rod reflection, the role of rod reflection to make it a relay path between a client and non-client peers, then we can basically increase the routing information that's available in the network, and so they can be used in path selection. So that's a basic observation, and here's the simple proposal that basically for this fix. Basically, the idea is that to allow a rod reflector to advertise different sets of routing information toward different types of peers. More specifically, when we advertise routing information to a client, we basically advertise a route from another cluster. So if we learn something from another cluster, we pass to the client, regardless whether it's best path or not. And on the other hand, when we advertise routing information to other clusters, we basically just advertise the routing information we learned from our client to other clusters. And in both cases, if the overall best path fits into meets the criteria, we should advertise the best path. Otherwise, we should advertise the group best path that is more useful than other paths in route selection. So that's the idea. Here, there are several advantages to this simple provision. The first one is this simple revision basically allows the more routing information to be made available in the network that can be used in path selection. In particular, this approach does not change the current rule that the BGP only advertises a single path for a particular prefix. So the memory usage is basically because of this, the memory usage is basically is bounded, similar to the situation of doing closest exit, because you only advertise single paths to the peers. And it turns out that this simple revision eliminates most of the route oscillations, especially the common ones, including the two cases that was shown earlier. This pretty much, it's very hard to actually quantify this as a protocol change because it only changes the semantics of route advertisement by reflector. It does not change any of the protocol formats or the other mechanisms. The very simple is much easier to implement and to deploy because you can just deploy on one router at a time. The disadvantage of this solution is that it does not eliminate route oscillation in all cases. We have a counterexample. It's sort of more complicated, but in that case it does change. So this is just a oscillation reduction. I think that's it. All right.
Okay, so Anchor's talked about kind of a nice backward compatible hack that improves the situation. And what I'm going to talk about now is some work that my co-authors and I did to think about, well, what happens if we don't want to, just kind of improve things, but we want to fix the problem altogether. Mic up? Okay. Okay, so just to recap, what are the factors that make BGP oscillate? It all basically boils down to two things. One is information hiding, which when BGP was originally invented, there was no notion of BGP hierarchy, and so it's not really surprising that BGP isn't robust in the face of not having complete information. And then to make matters worse, we've got this partial ordering thing with MED. So we really wanted to fix all of this. So a few observations. First, full mesh IBGP doesn't oscillate, and that's because all the routers in the network have what passes for complete information. So QED, we need more information in the network sometimes to suppress oscillation. So since hierarchy is all about hiding information, what do we need to do? We need to invent a mechanism that lets us send more routes through these aggregation points in the hierarchy through the route reflectors or confed ASPRs. So the trick that you want to do is be able to figure out just which additional routes to advertise without getting back to the memory complexity of full mesh IBGP. So the proposal that we came up with is really a proposal in two parts. The first part is an extension to the protocol which allows us to advertise multiple paths without the implicit withdrawal behavior that's in the current BGP protocol. And this is just an infrastructural thing. It can be used for eliminating churn by advertising additional paths. It can also be used for other things that may be useful also, and I'll touch on that briefly later. Then the second part is, given that infrastructural piece, what you want to do is at the route reflector, and I'm just going to talk about route reflectors from now on with the understanding that you can equally apply anything that applies to route reflectors to confeds also. At the route reflector, you want to advertise 0 or 1 group best routes, and by group best I mean the best for a given neighbor AS, from the cluster or sub-AS to your peers. And we observe that you only need to do this if the tiebreaker for choosing the route occurs below the med step. So that lets you prune the routing or the memory complexity a little bit more. There's other refinements that could also be pursued that generally apply to both this approach and what Anchor presented. For example, you can do something dynamic with detection of oscillating routes and only apply the algorithm to that. It's arguable whether you want to do that or not. And I'm not going to show cartoons of encodings or anything like that for the extension itself. You can look at the drafts, which are referenced in the end of the slide deck, if you're interested in stuff like that. So what are the benefits we get from this? Well, it says no. I wrote no constraints on topology. There's it reduces a lot of the constraints on topology that have been written into recent RFCs and drafts and whatnot, saying, well, you need to set your IGP metrics just so, and so on. There's still some basic fundamental topological constraints having to do with reasonable network design, but if we can do this trick of advertising extra routes, you can greatly reduce the constraints on your on the nature of a safe topology. So you don't have to introduce new full mesh requirements, for instance, between your confed ASPRs, and you can relax current constraints in IGP metrics. So I think the biggest benefit to this approach is it fixes the problem. It doesn't just make it appear less often. I think there's a lot to be said for fixing a problem as opposed to papering it over. And one important subpoint to this is that I believe that any complete solution to the BGP oscillation problem is going to require the ability to advertise multiple paths in BGP, in other words, to relax the implicit withdrawal behavior of current BGP. So to that extent, that motivates wanting to get the infrastructural piece, the multipath piece into BGP, regardless of whether you agree that the algorithm we presented for selecting exactly which routes to advertise is the right one or not. Finally, the multipath extension has other potential applications. For example, multipath BGP that's not a hack, and you may have, if you read the IDR list and have a strong stomach, you may have seen that there's been a lot of discussion recently about, oh gee, how do we do multipath BGP? Well, you don't have to discuss it that much if you have a way of directly expressing what your multipath route is. Another application is route server. Another application could be route monitoring, actually. So what are the drawbacks? There are significant drawbacks. There's more network state than the best external approach Anchor just presented. And the memory complexity looks like basically route reflection as it's spoken today is the least memory hungry. Best external is a little worse than that, multipath is worse than that, and then flat IBGP is the worst case. However, I'll observe that if you don't use MEDs in your network, if you don't allow MEDs in your network, the memory complexity of multipath is exactly the same as current route reflection because of the rule that says you only have to advertise the extra routes if the MED comes into play. And probably, to my mind, the biggest two concerns are implementation complexity. We're talking about some fairly fundamental changes to how we generate updates, and there's just a fair amount of code work. And then questions of how you deploy and transition to this thing. I think that these problems can be fixed, but it's not as transparently incrementally deployable. And there are some open questions, one of which came up when we were talking yesterday, so I thought I'd put it in, which is, well, doesn't this converge slower because you're advertising more routes? Well, you're transmitting more data when you advertise all these multipath routes, so that's slower, right? Well, but you've got all these new backup paths available that you don't have to transmit after a route's withdrawn, so actually convergence will be faster. I'm guessing that this will be faster. Your network will actually converge faster because you've got more backup routes available, but I can't prove it right now. And here's the references. There's a RFC that talks about the oscillation condition, and then there's two drafts. The first is, well, actually, I should have the second and third in the opposite order. The advertisement of multiple paths talks about the infrastructural piece. How do you advertise multiple routes at all? And then our proposal for exactly which routes you should advertise. And we'll be bringing this up at the IDR meeting in Atlanta. So I encourage you to attend if you're interested. Thank you.
So yeah, now we have this problem. So what do we? Until we have a solution deployed, what should we do in the meantime? So let me talk briefly about this route oscillation detection and also some deployment consideration and workarounds. First is route oscillation detection. It has been pointed out by multiple parties that the persisting route oscillation occurs only with a very small percentage of the routes and in certain network topology. However, if for the affected customer, this is a huge problem. because it's just your connectivity is constantly changing. So I think we think that we need to basically proactively work on this issue, basically to detect the occurrence. Once they are detected, I mean the workarounds, there are a dozen of different ways to work around the problem, and it's really very easy to fix them through configuration. And so it is noted that fully automated approach is really very difficult to get it correct. And so here we are suggesting that the protocol assistant detection matrix. I think the main thing is that we need to maintain the flat statistics for RBGP peers, for RBGP learned rods. Currently there is at least one implementation that is by Redback, has been there for a year now. Basically, you can do show BGP rods flat statistics internal. That will show all the rods that have been flapping at what frequency, and basically similar to the damping matrix without applying the actual damping. And then you can basically look at the rods that with the highest frequency, flapping frequency, and then basically investigate further. I think if the vendors implement this mapping, that will help a lot to the providers. So here are some of the deployment considerations. The first one, actually, this is it's really it is amazing. There are still some providers that have not enabled this deterministic BGP rod selection, deterministic MED knob in their configuration, and this basically was a bug in a couple of implementations, and that leads to inconsistent rod selection in your network, and this is very bad. This basically should be enabled everywhere. The bug has been fixed several years ago. And another point is that depending on your network size, you could consider fully mesh your RBGP peers. I mean, these days it's several hundred peers. A router that is doing several hundred peers is not really difficult to do. So if your vendor does not support it, cannot handle it, you should ask for it. And I mean, 500 plus peer sessions is really doable. Regarding rod reflection, actually some of these principles also basically applies to confederation, as Sue and John mentioned earlier. For the reflection, it is preferable to use a one-level rod reflection, because more levels you use, the less information will be made available, and you increase the chance of persistent rod oscillation. And before you go into multiple levels, you really need to think very hard why multi-level is needed. So is that because you are reaching like 100 peers or something like that? You really need to think hard and also work with your rod vendor to figure out if that's this 100 peer, is that a problem or not, before going into multiple levels. And the second thing is that all the clients within a cluster should be fully meshed. By fully meshing them, basically more routing information are made available, and you reduce the probability, the chance of persistent rod oscillation. And this MED, it has been shown MED, it has been causing different types of problems. So, but it is there. But you need to make a conscious decision. Basically, if you don't need it, don't use it. Or put it another way, use it only when needed. And another point is that when you design the rod reflection or confederation topologies, make sure that you carefully evaluate your network topology. One of the biggest factor right now is probably regarding the metric assignment for this inter-cluster metric versus intra-cluster metric. And it is not always possible, but if it is possible for your network, I mean the intra-cluster metric should be much larger than the intra-cluster metric. Then if you do that, you basically you have a lot more flexibility in choosing which router should act as a route reflector. It probably pretty much make it not an issue. Otherwise, this metric will play a very significant role in that decision. Another bullet is that this actually has come up a couple of times on the RDR mailing list. So here, what I'm suggesting is that do not transition the base path from one eBGP path to another eBGP path simply based on router ID, because that is just a random number, and assuming everything being equal. Actually, this feature is on by default for some of the implementation. It has been shown that this feature eliminates some router oscillations, because this router ID is really for eBGP. It's really random. You don't have any control over what number your eBGP peers will be using as a router ID. So it's a random thing. There's really no need to change the base path because of this. And finally, monitor route oscillation and doing workarounds, because this has a huge impact for the customers. All right, here's some acknowledgements. Yeah, that's all.
We left a good amount of time for comments, hoping that those people who cared, would make comments or ask us questions. If not, how many people, I'd like to see an informal, how many people are restricting their topology due to this? How many ISPs are restricting their topology due to these problems? A hand raising would be useful. Restricting your topology because you don't want to have multiple levels of route reflectors, or you don't want to have multiple levels of AS confederations? Okay, I see one. Okay.
I think that's an unfair question, because depending on how big your network is or how your business imperatives make your network design look like, you can restrict your topology because you can maintain that many number of sessions at the top level.
Absolutely.
So it's a good suggestion, but it's not necessarily applicable to all people, and we should try and solve this problem for all people regardless of size.
Okay, that's good input. Thank you. We are just looking for some input, because we ran into questions of what problem we're trying to solve. So I'm trying to poke at anybody who give us input. Go ahead.
Hi, I'm Tim Griffin from AT&T. Just some comments, maybe you can respond. First of all, the MED attribute is the one attribute that breaks the rule that says, the ranking of a path should not depend on the existence or non-existence of other routes in the table.
That's right.
And so that makes MED an odd attribute, and I would claim that the real problem there is that people cannot understand what they're writing when they write down their policies, because it has that sort of combinatorial semantics that you really can't understand what you're writing. In fact, you can come up with simple examples with full mesh IBGP that has non-deterministic routing when MEDs are involved. Okay, I can show you that example afterwards. But the point is that the real problem here is that we've got a broken attribute, right? Now, it has very weird semantics. The other thing is that you seem to imply that these non-termination problems with BGP have something to do with MED, or something to do with route reflectors, or something to do with their interaction, when in fact, it doesn't. It's built into the BGP protocol. You can get non-terminating policies.
The first example that we gave was without meds.
No, but it has route reflectors in it too. So you can just with 4 ASs get a non-terminating set of policies, and so it's built into the protocol. And you're seeing it with meds. Why? Because people can't understand their policies. They write these things down. They cannot understand what the policies are doing because of this. The fact that it's violating the fundamental rule of ranking just the route, not ranking depending on what's in the table. Okay?
John, I will let John go. Did it turn on? If not, you got mine.
Okay, so just to respond to the MED is a really weird attribute, and it's very hard to understand what it's doing. I couldn't agree more. And for a long time, I was arguing in favor of saying, let's please just get rid of this odd duck because it's a mess. Many of the people in this room responded rather forcefully that that was completely unacceptable. If the opinion of the operator community has changed since then, and everyone's happy to just stop using MED,
There'll be 3 people happy.
I would that would be just fine with me, and B, your router probably already supports it. You can just turn on the always compare med knob, and you're done.
Okay, but a year from now, 2 years from now, we're going to be here again talking about, people are starting to use very complex community attributes to do traffic engineering between autonomous systems. This is going to start causing oscillation eventually, especially when it's crossing autonomous systems that are in the same administrative domain, they're in the same company, where you're not constrained by the peer-peer customer-provider relationships. So the fact is that there's a fundamental problem built into the protocol. There's no guarantee of convergence. You just bumped into it with meds. You're going to bump into it again.
I think that's a distance vector discussion, right?
Yes, it is, and that's exactly what's happening here.
Mm-hmm.
It just happens because people can't understand their policies. That's just my opinion.
And you're entitled to it.
Yeah, thank you.
I guess actually I do want to respond just briefly to the second part of your comment, which if I'm paraphrasing it correctly, is that BGP is a distance vector protocol, and it has a non-convergence problem in other cases other than MED. The point is well taken. However, I do think it's the case that for that the MED convergence thing is a significantly greater problem than some of these other things that you and others have shown. They're interesting cases. It would be really nice if the protocol provably converged in all cases.
It's just when we bump into it first.
Yeah, and
Bump into it again, I'm sure.
yeah, I'm wondering if you are talking about I remember you and your colleague have a couple of papers on that, talking about probably the global policy versus local policy involving multiple ASs, and show that there will be some persistent isolation. Yeah, some of this said about interesting, but they are actually, I think the probability of them occurring in practice is lower than this RBGP situation due to the different policies being applied on RBGP boundary.
Well, that may be true now, but will it be in 3 years when people are doing very complex policies with using communities? I don't know. And I don't think anyone does.
Well, yeah.
I do, but I'm not telling. Only joking.
John's got his crystal ball back here. You can see it. Any other questions? Comments? Any other thing I can poke out of comments. We welcome comments about this. Alex, I think that summarizes my attempt to get more input for you. I've tried. You going to try, Dave? Any other ISPs that want to make comments? I mean, there's a lot of really interesting statistics about problems with oscillation. We've seen really good things. We're trying to find what you want to do with this.
So I do strongly encourage people to speak up because we've been trying to solve this problem for, I think, 4 or 5 years now. Mm-hmm. We have data that shows that about 1% of the internet currently deployed is subjected to this problem, and we have a couple of fixes. We can not turn on meds, or you can not pay attention to meds. You can restrict your topology. We can put in a change to the protocol, which will be internal only, change the algorithm as Eka presented. We can have more significant changes that will solve this problem and other problems into the future, but we'll have some deployment considerations, or we can continue to do nothing. Right now, the only thing that we can do is what we've done for the last 5 years, which is continue to do nothing because there's no consensus whatsoever. So I highly recommend that we come to a resolution on what we want done.
If there's enough pain, tell us so we can fix it. If not, we'll keep doing nothing.
This is not also an offer to stop giving presentations about this if everyone's sick of it.
Yeah, we'll stop talking. Go ahead.
I have 2 points. I think one of the problems, and I'm sure most of us would agree, is it's encouraged, or at least it's been based on the literature. And when I say the literature, there's probably one book that everybody here that's on its second revision would agree is something a lot of the smaller corporations, companies that are peering or purchasing transit are using to build their configurations, and that is to use MED as a way to influence inbound traffic. And doing it in any other way involves communities and matching community values so that your upstream provider can set local preference. And that's not something that's very well socialized. So we're still going to see this explosive use of a broken attribute. I think the second point would be that a lot of ISPs are still using or translating IGP distance into MEDs and then announcing that. And I think in the previous presentation when we saw those S-path updates, I think that's likely what the cause was, because NIMDA was breaking a lot of internal links or breaking Ethernet LANs or whatever, which was causing some topology changes in the IGP, which was then reflecting itself in the MEDs that were being reflected or being announced outside the network. So I think while we're still doing that, we're going to continue to see these type of oscillatory problems with MED alone, and then to the previous point, we're going to see with other experts as well if we keep trying to marry the IGP and its inherent instabilities with BGP. Is that enough to swallow? I'm sorry.
Let me comment on that. I certainly agree with your opinion on this regarding the use of MED. I think the MED has been deployed, widely used for probably more than 8 years now. I don't think we can tell ISPs and customers to stop using that because it's already deployed so widely. I mean, it's just you cannot change it. And also, as one of the slides shows that this right oscillation actually can occur without involving the MED at all. So it seems to play a less role than what we have been thinking. So and also the two solutions, one is for the reduction, the other is the elimination. Basically, do not make assumption about not using MED.
I agree. I think that's fine, and I'm more in line with John's points, and I think both your points, that we can increase the amount of information that we're sharing among BGP speakers to get rid of this loss of information problem, especially with this kind of stratified decision process that can change based on where you are in the network. So if it's not a MED problem, that's fine, but it could be other problems down the road, and I think maybe we need to start analyzing what those potential failure modes can be beforehand.
Alex Zinin, I'm going to speak up as the routing inter-directory relative and support the working group chair, Dave, and people who spoke up. There's perceived at least problem in the ETF that the service providers are not being listened to, and that we're ignoring input from you. I would like to say that consider this as an explicit invitation to provide your feedback, and we need it. Please read the drafts, work with the working group chairs, work with the authors, speak up on the mailing list. It's now very active, so you're not going to look like you're the only one speaking there. It's going to be pretty comfortable. And let's not, after this meeting, let's not go away and forget about it, like, okay, good words have been said, forget about it till the next meeting. Let's do something. And until we do something, until you guys actually read the drafts and provide the feedback to the ETF working groups, nothing's going to happen. At least nothing that will satisfy you guys.
Go ahead, please.
Yeah, I just have one comment. I think that clearly solving the convergence problem is desirable. I would say even going one step further and knowing that not only will the protocol converge, but knowing that it'll converge to a particular solution that can be predicted from the inputs. But what I mean by that, just to pick a really small example, is this notion of disabling use of router ID. One of the suggestions that came up in the last presentation. If you get a new route that's better only in terms of router ID, not switching to it, one disadvantage of that is it becomes difficult from a static snapshot of the routes learned from neighboring domains to actually predict the routing solution the system will have. And this makes it incredibly difficult to debug or to have prediction tools for traffic engineering that depend on being able to know what the routing output will be for a given set of policies and a given set of inputs. Making things dependent on order and timing seems very risky if you want a predictable system.
Yeah, that's true. However, I like to point out that if you do have a preference, if you want to favor one path over another, basically there are multiple ways to do it. Including local preference path, all of this stuff. If that's what you want. If you really don't care, it's really. The decision process, the right selection runs all the way down to right ID. You are going to get it in sort of random outcome.
I think if you're bound to get that, though, with multi-homed customers, you end up having the same AS path length. And a lot of the other attributes may be identical, may even be the same exit point, so the IGP metrics may be the same as well. So it's not obvious. In a large ISP backbone that connects to peers with lots of multi-homed customers, it could very easily happen that you get down to the router ID tiebreak. Now, granted, deterministic output of the system may be less issue compared to oscillation. Oscillation is a much more serious problem, but it might be nice to have a solution that solves both problems rather than focusing just on the oscillation problem.
Thank you. I don't know your name, so if you'll announce.
William from Milan Communications. I wanted to kind of ask a person from Cisco how hard it would be to put something that would allow Cisco to keep track of route changes. For example, if route has changed in the last 2 minutes, you would be able to keep some kind of history and see if it happens too often, and then just stop announcing, at some point stop sending mails. It seems to be like an intermediate solution that's not very hard to do.
Are you talking about having an automated system to detect the fact that an oscillation is occurring, or are you talking about an automated system to detect it and then transparently fix it, or are you talking about something else?
Probably both, but the second one, automatically fixing it, might be better left to the engineer to decide whether they want it.
I agree. I think that it's very reasonable to ask for an automated way of detecting that the problem is occurring, and that's what Ankur referred to in his talk also.
I
Right,
think I put that up for you behind.
The most important thing is basically to keep a history of all BGP changes within the last.
Yeah, that's what it does. Currently, if you look at pretty much every router vendor has implemented router flat damping based on Curtis' work. And that code can be easily, that applies to eBGP today. That code can be easily adapted to maintain statistics for RBGP. And it's probably a couple of days work, that's all.
Okay, so why don't we do it?
You're probably right.
Okay. Why don't we do it and allow some engineers to work with it and then decide on some other future meeting if it's working well or not?
So probably can have it done tonight.
Please let your account team know.
BJ?
Okay, just to reinforce what Jen was saying earlier, non-deterministic path selection based on order of in which you received the route is not acceptable. We actually had that turned on for us by Cisco, who were trying to help us get a better load distribution. The first thing we did after a couple of router reboots, totally changed our traffic patterns, was to turn the stupid knob off. So that's, at least for us, that's not a viable.
Yeah, maybe I can respond to that. At that time, I was still at Cisco, and it was a bug. It was fixed.
Okay. Any case.
Can you boys take that one outside?
No, I mean, this is something that is still in 12.021. You know what I'm talking about, John. And the second part is, it's not that ISPs don't really know what we are discussing here. It's that most people don't care. So if you can fix this problem by sending more BGP information, and our memory usage gets from 80 megabytes to say 100 megabytes, most people will not care. Just go ahead and fix the problem and just put it in. I mean, you've already done enough stuff to us that this will be a minor change in the entire history of it. So just fix the problem.
Yeah.
Like, don't wait for incentives from ISPs. You're sitting here waiting for ISPs to come to you to tell you what they want. And the thing is, most people don't know what it is that they want, and B, they don't care. Well, maybe 20 ISPs who will understand what we're talking about here in the entire internet, and out of those, maybe 3 are here.
Yeah.
So I suggest you just fix the problem and not tell anybody about it. Thanks.
So as you see, there are a couple of solutions on the table. I think we'll fix this one way or the other. But regarding the memory utilization, how much increase it will be, it really depends on whether you are using closest exit or not today. If you do, then it probably will not increase much. But if you do not, once you turn this on, it can double or triple the memory utilization.
Comment. I don't know why you're talking about route flat dampening. Route flat dampening just makes persistent oscillation go real slow. And you know what? It doesn't get rid of the oscillation. It makes it harder to debug.
I think you're missing Anchor's point, which is that the machinery that you use for route flat dampening can also be used in basically a listen-only mode to identify flapping routes, so that the operator can do something about it by hand.
Yeah, just maintain statistics for RTGP routes, not dampening.
And then how does the operator tell that this is due to NED and not something else?
That's how they earn their exorbitant salaries.
And that's why we spend so much money on things like that, isn't it? I mean, this is a very difficult thing to debug.
But I think this is the first step, right? At least you have some tool to deal with it.
Right. Your point is taken again, but I think we need to, crawl before we can walk, before we can run.
I think most of the ISPs already know about this problem. The problem is that our customers don't understand why we don't carry the traffic to the closest peers. Let's just say from DCA to Sunnyvale or something. Most of our customers get very upset when we hand off the traffic at the closest exit instead of us carrying the traffic as much as possible. Yeah, so it's more of a business reason than a technical reason.
Okay, thank you. Jeff, and then that's the last question. Susan tells me we're out of time. Thank you for the input all.
It's not even a question, it's just sort of suggestion based on an earlier comment. We who are implementing BGP probably should provide to our users output that show, when we do show IP BGP or whatever, that shows where the tie breaking is happening. So people who are trying to do something like traffic engineering can say, well, we're tie breaking at router ID, do it differently.
Yep, this is probably a very good comment. Okay, thank you very much for the input. Please don't make it the only input. Alex and I are pleading. I think we're down to, and VJ, we did hear just fix it. That's a really good input too. Thank you.